Welcome to The Explainer. Today, we're diving straight into a phenomenon that is fundamentally reshaping how we interact with technology: the chaotic, sometimes dangerous, and surprisingly innovative world of AI hallucinations. We're looking at the very real consequences of artificial intelligence failures. We're talking about everything from chatbots inventing totally fake legal cases to airlines getting sued over hallucinated refund policies, and the urgent race to figure out exactly why these highly intelligent systems so confidently just make things up. We're not just talking about a chatbot flubbing some song lyrics here. We are talking about generative AI confidently presenting completely fabricated information as absolute truth. When a machine states falsehoods with quiet, unwavering authority, the ripple effects are massive. They can disrupt courtrooms, destroy academic integrity, and throw a huge wrench into everyday business operations. To really wrap our heads around this, we'll first define the core problem, trace the surprising origins of the term itself, and dig into the technical why behind the hallucinations. From there, we'll explore the real-world fallout, uncover some incredibly surprising scientific benefits, and finally, look at how the tech world is scrambling to fix these flaws. Section 1. The AI hallucination problem.
So what exactly is an AI hallucination? Basically, it's when a model generates a response packed with false or misleading info, but serves it up as an absolute hard fact. Now, despite the psychological name, the machine isn't daydreaming or experiencing a glitch in the matrix. It's actually just seamlessly weaving together plausible-sounding, completely random falsehoods, inventing fake names, dates, or concepts that look incredibly legitimate to the human eye.
You know, a lot of experts actually hate the word hallucination. Researchers like Usama Fayyad and Mary Shaw make a great point. It unfairly anthropomorphizes the software. It applies human psychology to a machine that's really just doing statistical pattern completion. So, in scientific literature, you'll often see alternative terms used, like confabulation or fabrications. Or if you want to get blunt about what happens when users rely on these models completely uncritically, there's the highly technical, somewhat derogatory term, bot shit. Section 2. Origins of the term. Where did this psychological term even come from in the context of computer science? It's a pretty surprising timeline. Believe it or not, back in the 1980s, hallucination actually had a totally positive connotation. It was used in computer vision to describe the really useful process of adding extra detail to low-resolution images. Fast forward to the 2000s, and it started being used to describe failure modes in machine translation. By the 2010s, it shifted again to signify factually incorrect AI outputs. But, as you probably guessed, it wasn't until late 2022, when modern chatbots exploded onto the scene, that everyday folks started noticing these systems just confidently making things up. That is when the term went completely mainstream. Section 3. Why do models hallucinate? Let's peel back the curtain on the technical mechanics here. Why do these massive language models make such confident errors? Well, the root causes are baked right into the models themselves. First off, the whole point of generative AI pre-training is predicting the very next word in a sequence. This literally incentivizes the system to guess, even when it has zero clue what the actual answer is. Second, there's this constant tug-of-war between novelty and usefulness. If a model leans too hard into novelty, sure, it generates highly original text, but it's totally inaccurate. And third, this is wild. Recent interpretability research by Anthropic showed that these models actually have internal circuits designed to basically say, I don't know. But when a model vaguely recognizes a topic but lacks deep knowledge, those safety circuits are incorrectly inhibited. It overrides its own safeguards. But it's not just the internal wiring. We have to look at the data feeding the system too. If the training data sets are incomplete, inaccurate, or just unrepresentative, the model is practically forced to hallucinate patterns that don't actually exist. That's a phenomenon known as input bias. Add to that the risk of adversarial attacks, where bad actors subtly tweak input data to intentionally confuse the AI, and things get messy fast. When you use an AI for research or a daily task, you're ultimately putting your trust in the invisible integrity of millions of raw data points. Section 4. Real-world consequences. So what happens when these flawed systems are actually deployed in high-stakes environments? Well, in the 2020s, some law firms adopted generative AI, and it caused absolute chaos. Take the famous case against the airline Avianca. A lawyer submitted a brief to a New York federal court that contained 6 completely fake case precedents generated by ChatGPT. The chatbot literally invented the cases out of thin air and even doubled down on their authenticity when questioned. The fallout resulted in blistering reprimands from federal judges. They pointed out that these programs hold zero allegiance to the truth, the rule of law, or the Constitution. They act only on their programming, completely unbound by any sense of duty, honor, or justice. And the fallout extends deep into academia and business too. Take a look at this number, 47. In one medical study, researchers discovered that 47% of the academic references provided by a major language model were completely fabricated. We're talking fake authors, fake studies, non-existent digital identifiers. It's a massive risk for academic integrity. And the corporate world is feeling the sting as well. In 2024, a Canadian tribunal forced Air Canada to pay damages because its support chatbot hallucinated a bereavement fare discount policy that did not exist. The airline actually tried to argue that the chatbot was a separate legal entity responsible for its own actions. The tribunal obviously rejected that completely. Section 5. The surprising scientific benefits. Now, despite all of these massive headaches, there is a totally unexpected twist. These so-called flaws are actually driving some unbelievable scientific progress. It is absolutely crucial to contrast how hallucination operates in different contexts. On one hand, you have chatbot hallucinations, generating ambiguous language, fake quotes, and ungrounded internet data. That is incredibly dangerous. But on the other hand, you have scientific hallucinations. When you take this exact same generative capability, but rigorously constrain it with the scientific method and ground it in physics, it becomes an absolute superpower. Instead of making up fake legal cases, the AI is unleashed to hallucinate totally new physical structures that have never existed in the universe, which researchers can then physically test and validate in the real world. And the results are literally world-changing. At the University of Washington, David Baker's lab used AI hallucinations to design millions of novel proteins that simply do not occur in nature. This massive breakthrough actually contributed to Baker winning the 2024 Nobel Prize in Chemistry. Though, it's worth noting the Nobel Committee carefully called it imaginative protein creation rather than hallucination. And over at Caltech, researchers used this same phenomenon to design incredibly intricate medical catheters. The AI hallucinated designs with tiny sawtooth-like spikes on the inner walls to stop bacteria from gaining traction, aiming to severely reduce urinary tract infections. In these tightly controlled physics-based environments, the AI's ability to hallucinate is immensely accelerating the pace of human discovery. Section 6. Mitigation and Future Outlook. Knowing both the mind-blowing benefits and the terrifying risks, how is the tech industry actually working to fix the downsides? Well, enterprise organizations are heavily relying on a few foundational mitigation strategies. Step 1 is feeding the models high-quality, balanced data to stamp out that input bias. They're also using data templates, which provide strict, predefined formats that severely restrict how the AI is allowed to answer. But right now, the most important strategy is just us. Human oversight remains the ultimate critical backstop. Having a human manually validate and review outputs is currently the absolute most reliable way to filter out those convincing fabrications before they do real harm. But engineers aren't just crossing their fingers and relying entirely on humans. They are actively testing advanced technical interventions. For example, researchers are testing multi-agent debate. This literally forces different AI bots to argue with each other until they can reach a factual consensus on a single answer. They're also exploring neurosymbolic architectures, which mash up modern neural networks with old-school formal logic and knowledge bases. Companies are deploying scripted guardrails, like NVIDIA guardrails, which hard-code specific responses for sensitive topics rather than letting the AI guess. And finally, they're looking at confidence scoring. This is where models evaluate multiple potential replies and assign a certainty metric before speaking. It's super effective, though it does significantly multiply the computational costs. Which brings us to a final, really provocative thought. AI hallucinations represent this profound, fundamental tension between pure creativity and cold, hard truth. When you constrain it by the laws of physics, this exact same quirk wins Nobel Prizes. But when you unleash it on the open internet, it invents legal precedents and spreads misinformation. So as these models scale up and become even more deeply integrated into our hospitals, our courts, and our daily lives, we have to ask, will technical interventions ever completely eliminate the machine's inherent hardwired drive to confidently guess the unknown? Or will human oversight, critical thinking, and validation forever remain our final, absolutely necessary guardrail? It's a question that is quite literally going to define the future of technology. Thanks for joining this explainer.